The philosophical implications of modern physics, the answers to our most important questions in life. Modern physics has challenged and expanded our understanding of reality through its exploration of the universe, quantum mechanics, and relativity. The philosophical implications of these developments are profound, as they touch on fundamental questions about the nature of time, space, causality, free will, and the origin of the universe. This video will examine the philosophical implications of modern physics. 1. The nature of reality. From classical to quantum worldviews. Classical physics, rooted in Newtonian mechanics, presented a deterministic and predictable universe. The laws governing motion, gravitation, and energy were seen as absolute and unchanging, leading to a mechanistic view of reality. However, the advent of quantum mechanics and Einstein's theory of relativity transformed this perspective, revealing that reality is far more complex and uncertain than previously imagined. Quantum mechanics, with its uncertainty principle and wave-particle duality, challenges the classical notion of determinism. In the quantum realm, particles do not have definite positions or velocities until they are observed, introducing an element of indeterminacy into the fabric of reality. This has led to philosophical debates about the nature of existence, the role of the observer in shaping reality, and whether the universe operates on purely probabilistic principles. Relativity and the fabric of space-time. Einstein's theory of relativity further complicates our understanding of reality by linking space and time into a single continuum, space-time. According to relativity, the experience of time is relative to the observer's velocity and gravitational field. This has profound implications for our understanding of causality and the flow of time. It suggests that time is not a fixed, universal backdrop but a dynamic and flexible entity shaped by the conditions of the universe. Philosophically, this challenges the traditional linear view of time and raises questions about the nature of the past, present, and future. If time is relative and malleable, then our experience of it may not reflect the true nature of the universe. This leads to deeper inquiries into the nature of temporal reality and whether the future is as real as the past and present. 2. The limits of human knowledge. The quest for a unified theory. One of modern physics's central goals is searching for a unified theory that can explain all the forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, within a single framework. This quest for a theory of everything reflects humanity's desire for a comprehensive understanding of the universe. However, despite significant advances in physics, such a theory remains elusive. This raises philosophical questions about the limits of human knowledge. Can we ever fully comprehend the workings of the universe, or are there fundamental aspects of reality that will forever remain beyond our grasp? The pursuit of a unified theory highlights the tension between our intellectual ambitions and the inherent complexities of the cosmos. The role of uncertainty. Quantum mechanics, particularly through Heisenberg's uncertainty principle, introduces an element of unpredictability into the universe. This challenges the classical notion that with enough information, we can predict the future with absolute certainty. Instead, quantum mechanics suggests that there are fundamental limits to what we can know about the state of the universe at any given time. Philosophically, this raises questions about the nature of knowledge and whether we can ever achieve complete certainty in our understanding of the universe. It also touches on issues of free will and determinism, as indeterminacy at the quantum level may imply that not all events are predetermined. 3. The nature of time. The arrow of time. One of the most intriguing questions in modern physics is the nature of time and why it seems to flow in one direction, from the past to the future. This arrow of time is closely related to the second law of thermodynamics, which states that entropy, or disorder, in a closed system always increases over time. This gives time its apparent forward motion, as we observe the universe moving from lower to higher entropy states. However, the fundamental laws of physics, including those of quantum mechanics and relativity, are time-symmetric. This means they do not distinguish between the past and the future, leading to philosophical debates about the true nature of time. If the laws of physics do not require time to move in one direction, then why do we experience it that way? This opens up questions about the relationship between time and consciousness and whether the flow of time is an illusion created by our subjective experience. Time travel and causality. The possibility of time travel, suggested by the theoretical existence of wormholes, further complicates our understanding of time and causality. If time travel is possible, it raises paradoxes such as the famous grandfather paradox. where a person could potentially prevent their own existence by traveling back in time and altering the past. These paradoxes challenge our understanding of cause and effect and suggest that the linear, deterministic view of time may be incomplete. Philosophically, time travel raises questions about the nature of free will and whether the future is fixed or malleable. If time can be manipulated, then the boundaries between past, present, and future become blurred, leading to profound implications for our understanding of reality. 4. The role of consciousness, the observer effect. One of the most striking implications of quantum mechanics is the role of the observer in shaping reality. The famous double-slit experiment shows that particles behave differently when they are being observed, suggesting that consciousness plays a fundamental role in determining the outcome of quantum events. This leads to philosophical questions about the nature of consciousness and its relationship to the physical world. Is consciousness an integral part of the universe, shaping reality through observation, or is it merely an emergent property of complex physical processes? This debate touches on issues of dualism versus materialism and the nature of the mind-body relationship. If consciousness does play a role in shaping reality, then our understanding of the universe may need to be fundamentally rethought. Free will and determinism, the interplay between quantum mechanics and consciousness also has implications for the age-old debate between free will and determinism. If quantum events are inherently indeterminate, then this may provide a foundation for free will, as not all events are predetermined by prior causes. However, if consciousness is merely an epiphenomenon of physical processes, then free will may be an illusion, and the laws of physics may entirely determine our actions. Philosophically, this raises questions about personal responsibility, moral agency, and the nature of human decision-making. If our choices are not entirely free, then what does this mean for our understanding of ethics and justice? 5. The origin of the universe, the fine-tuning of the universe. One of modern physics's most profound philosophical implications is the apparent fine-tuning of the universe. Many of the fundamental constants of nature, such as the strength of the gravitational force and the charge of the electron, appear to be precisely calibrated to allow for the existence of life. If these constants were even slightly different, the universe would be inhospitable to life as we know it. This raises questions about the universe's origin and whether this fine-tuning results from chance, necessity, or design. Some see this as evidence for the existence of a divine creator. There are other views that it could also be explained by the multiverse hypothesis, where our universe is just one of many with different physical laws. These are some of the controversial issues of modern physics. The purpose of the universe. The ultimate question posed by modern physics is whether the universe has a purpose or meaning. The laws of physics describe how the universe operates, but they do not explain why it exists or what its purpose is. This leads to philosophical debates about the role of science in answering existential questions and whether the search for meaning is a scientific or metaphysical endeavor. While some argue that the universe is a purposeless, random occurrence, others believe that the search for a unified theory of physics may eventually reveal a deeper purpose behind the cosmos. The question of meaning in the universe remains one of the most profound challenges in both science and philosophy. Conclusion: modern physics has dramatically expanded our understanding of the universe, challenging long-held assumptions about reality, time, and causality. The philosophical implications of these developments are profound, raising questions about the nature of knowledge, consciousness, free will, etc. As science continues to push the boundaries of human understanding, it also deepens our engagement with the fundamental mysteries of existence. Through the works of thinkers like Stephen Hawking and Georg Unger, we are invited to explore the physical universe and the deeper philosophical questions that arise from our attempts to understand it. References: Hawking, S. 1988, A Brief History of Time, Bantam Books. Unger, G. 1967, Basic Concepts of Modern Physics, Verlag Freies Geistesbahn. Hawking, S. 2018, Brief Answers to the Big Questions, Bantam Books. Thanks for watching. Don't forget to subscribe to the channel for your success. If you like this video, please give it a thumbs up.